This evening, weather permitting, we have a little experiment. Down in the right, you see my rectifier and capacitor rig. Down on the left, there's the slow-mo camera, and if I pan the camera up, there is a little switch with blue wires, the lamp that is the ballast for the rectifier, and the voltmeter attached to the output. That little switch was installed on a golf cart for the headlights. However, exposure to rain and saltwater air caused the contacts to corrode. On and off are about the same now. However, I'm curious to see what will it do when we give it 200 volts instead of 12 or 400 volts instead of 12. Will the oxide break through and allow current? All zoomed in, set up, there's voltmeter, the light will come on if any significant current is allowed to flow, and let's see what the switch does. The slow-mo camera will capture anything funny that happens. Power on. There it was. Gonna have to look at the footage there because got so startled, didn't see what voltage it went at. But we got a little bang. As you can see, the oxide has been punctured. When I turn up the voltage, the light comes on. The switch is now able to pass current again. What do you know? The switch works and is also not welded. That is very interesting. Since no video on this channel is complete without a little bit of fun and follow-up, I have now connected the 800-watt space heater into the ballast circuit instead of just a 25-watt incandescent lamp. The switch is in the on position. I will pass a few amps of current through it, and then I will use this fiberglass pole to click it to the off position. Who knows, we might get a little bit of arcing. Nope, no arcing, though we probably will get a bang when I turn it back on. Pop! That wasn't too exciting. See, let's give it a little more current. 6 amps now. Nothing at all. Boring. Since the switch test was pretty boring, I decided to go for a magic smoke release from this cheap, nasty computer fan. It's one of the silly ones with the LEDs on it, and most of the cost has gone into said LEDs. The bearings are crappy, and the motor doesn't have enough power to push air through any sort of grating. The only good thing about it is it's silent, but other than that, it's useless. Time to blow it up. 800-watt space heater as ballast. Variac and rectifier is in straight 0 to 200 volt mode. As normal. Crank it right up. 2/3 of an amp. Bangity bang bang. And I think it's dead. Here's even more fun and follow-up to the switch experiment. This time, I've brought out the MOT and the water resistor. The switch is connected up there to the secondary of the MOT. This time, I will apply power with the switch contacts open, see if a 250 volt AC switch will withstand 2000 volts AC. If nothing happens, then I will close the switch briefly and open it again using the fiberglass pole as isolation. Hopefully, that will get some arcs and fun. No change. The switch will successfully withstand over 2000 volts AC. MOT on. Close the circuit. And open it. After some off-camera fiddling, it seems the switch has permanently melted into the on position. It's dead, and thanks for watching.